Welcome everyone to PASS Virtual Summit 2020. And thanks for attending my session today, which is Understanding Machine Learning Algorithms through Examples. I'm Anupama Natarajan. I'm a consultant. And before we get into our session, so I want to just explore everything that PASS currently offers for all the different data professionals across the world. So you can become a pass pro member, which means like you can unlock exclusive training and networking that is available, and just keep watching the pass pro membership space, because there are a lot of things getting added as we go along. And of course, like you would have heard about the pass local groups. These are the local communities who run your user groups in your favorite cities and countries. And similarly, the pass SQL Saturday event that is running across the globe. And these SQL Saturdays again run once a year in different cities. And I'm a SQL Saturday organizer. I'm really proud in mentioning that. And of course, PASS also has got a few other things like the virtual groups and PASS Marathon. And of course, like nothing can run in PASS without the volunteer support. So thanks for an organization like PASS supporting all the data professionals and the community across the world. So with that note, like session evaluations are really important for speakers like us. So make sure once you finish attending the session, fill your evaluations and submit it before the 20th of November, 5 p.m. EST time. So keep the time zone in mind, and especially if you are participants attending the session from across the world. So this particular session, which is around understanding machine learning algorithms through examples, is part of the machine learning pathway. I think with the PASS Summit, since I think last couple of years, like PASS have started introducing the learning pathways. So this is going to help attendees, like if you want to focus on a particular topic, you can start from like a level 100 and then move on to level 200 and gradually on to advanced topics. So with this year PASS Summit, like we have a machine learning pathway, and you had the first session, which is introduced by Buck around machine learning, artificial intelligence, and deep learning explained. And the current session that you are attending is part of the second part, which is level 200, which is understanding machine learning algorithms through examples. And the final session, which is going to happen later tomorrow, which is from Leela Itati, my friend from New Zealand. So she's going to be taking up a topic around Microsoft Automated ML, the next generation of machine learning. So without any further delay, let us jump on to today's session. A little bit introduction about me. As I said, I'm Anupama Natarajan. I'm a data and AI consultant, and I have my social media channels listed here, so you can reach out to me after this session for any questions or any clarifications. I have 20 plus years of experience working in the IT industry. I'm a Microsoft MVP for AI, as well as a Microsoft certified trainer and speaker. I do organize the local user group events and SQL Saturday events. And of course, I speak at a lot of conferences across the world. And I'm based in Wellington, New Zealand. So that's a bit about me, and let us look at the agenda for today's session. So in today's session, the focus is going to be more around machine learning algorithms. So I have kept this session in such a way, like assuming people are new to machine learning, and they want to understand what machine learning algorithm is and what are the different types of algorithms, common algorithms that are available, and how do you go about choosing the right algorithm. So we will kickstart the session with what machine learning is, what are the different challenges that are associated with the machine learning, and how does a typical machine learning process looks like, and where does the machine learning algorithm fits in, and how do you choose the right algorithm to solve the right problem. And of course, like I will just give you an introduction about the Azure Machine Learning Tools, but I'm not going to deep dive in this session around those tools. And I think in the next session, which Leela Itati will be presenting, like you will get to see some of these tools in there. And finally, I will leave you with some references in my slide pack, and that will help you to go and look for more information about the machine learning algorithms. And finally, I'll take up the questions towards the end of the session. Feel free to put your questions, but I'll be looking through the questions towards the end of the session. So with that note, let us get started with what machine learning is. So if you want to look at machine learning in a broader sense, it is actually a data science technique, which normally allows computers to use existing data or your historical data so that you can forecast your future behaviors, your outcomes, or trends for your organization. So if you think about machine learning, basically computers are going to learn that without explicitly being programmed. Normally we write programs and then the computers execute the programs, but with machine learning, it is going to be learning without us giving a lot of instructions to that. And a lot of forecasting and predictions from machine learning helps applications to become more intelligent, which means the organizations can be much more proactive and they can just cater for their customer expectations well ahead of the game. So a typical example of what you think about machine learning is like when I was introduced to machine learning, this is years, like I would say in advance, like I just jumped onto Amazon, and normally I purchase a lot of things from Amazon, especially around the books, and I have a typical search pattern. So I look for a lot of technical books, and so it was quite interesting to see, like as and when I search for some technology topics, like how Amazon gives me recommendations and things around that. So that's how initially I started with, oh, okay, what is this? That's recommendations are coming through, and this looks cool. And as a buyer, like it gives me more options to explore, and of course, it makes me to spend a bit more money. And I didn't look at that aspect. I looked at more around the advantages I got out of, like, okay, I don't need to go and search for these topics. So because I was searching books on machine learning, now I get to see all the different types of books that are already available in the market. And same thing if you look at use cases like transactions. Like I travel across the world, and I take my pretty much use my credit card to spend. And sometimes, like, it is always good to understand, like, okay, if there is any type of fraud transactions that are happening using my credit card, so that my banks can immediately suppress my or block my credit card. So these things are really good because in this case, like, you have to have real time monitoring of all the transactions, and the banks can act upon immediately. And that's where machine learning can help banks in terms of finding anomalies and patterns of fraudulent activities that are happening. And if you want to go for a much more simple use case around where machine learning can be really handy is like you would have seen a lot of robot vacuum cleaners these days, and it will machine learning helps the robots to basically decide on, oh, okay, have you done enough cleaning, and this is the time to stop or not. So these are some practical use cases where machine learning can add value for organizations as well as for consumers. So what are the key challenges you face with machine learning? So the first and foremost is always being the volume of data. And for machine learning algorithms and the models to be more effective, like, you need to have a large volume of data if your organization has already got that, because then it is easy to train your models and also to test your models accordingly. The second part is your access restrictions. As I said, data is really important and key for machine learning models. But if you have restrictions around like how much data you can really use for your training, then probably that is going to impose you some challenges because you can't train your models effectively, even though if you have a large amount of data sitting in your organization. The third item is around data privacy. So as you know, what information that you can use and how do you make sure, because ethics is more important even when you're using machine learning algorithms and creating models, and as well as like how do you make sure like you don't make decisions based on bias. So data privacy also plays an important role, and with a lot of regulatory and data privacy requirements organizations have got, like, you need to be really careful, how do you choose the right data for your training as well as testing purposes. The next challenging part, which I have seen in a lot of organizations, is around the learning curve. So you want to use algorithms, right? This particular session is all about how do I go and choose the right algorithm to solve the right to solve the problem. And how do I go about doing that? Like, there is a whole heap of algorithms in there. How do I find out like which is the right algorithm to solve this problem? Initially, like, you may need to have some expertise, experts in your organization that you may need to reach out, especially your data scientists, until you get familiarized with some of these algorithms and the patterns or the outcomes that it is producing. And finally, like domain expertise, and this is really important, both from what type of data I need to be using in order to find the results for this problem. Because you may have a lot of columns in the data set, but only a few columns that you really require will determine certain use case scenarios. So for instance, I talked about the credit card for fraud related use case, right? So if you want to think about that use case, what are the things that you need to know? Like, okay, which country I'm using the credit card, what time of the day I'm using the credit card, at which location I have been using the credit card. So these are some of the like attributes that are really important in order to figure out whether the transaction is being done as a fraudulent transaction or not. And these type of metadata is what is your domain expertise can help you with. So if you have like 200 columns in a data set, you don't need all the 200 columns in order to find a solution for your problem. So where your domain expertise can help you with that. But having a knowledgeable domain expertise on different domains in an organization again becomes a bit challenge. So we looked at how machine learning can help organizations. We also looked at some of the challenges that comes with machine learning. But how does a typical machine learning process looks like? So where does like the topic that we are talking about, like algorithms, fit into the whole machine learning life cycle? So if you look at this diagram, so machine learning process always starts with the raw data, and finally it ends up with a model derived from that particular data. And it can sound as simple like a single line statement, but the process that you have to go through is not that simple. And that's where like Microsoft is helping you to use the tools that are available on Azure in order to make this process really simple for users. So if you think about this, you get the raw data and you do a little bit of pre-processing of your data in order to prepare your data. So this is one of the important process, because as data professionals, we know like not all the data that we'll be receiving either from internally from our organization or externally from different organizations are going to be clean. So you have to do a bit of data cleansing activities. And again, the focus has to be around the columns that we are interested in order to solve the problem. So there is a bit of pre-processing even before you collect the data, and which I haven't mentioned in this diagram, which is about like understanding what is the problem you're trying to solve. So in machine learning, that is one of the things. So you can't solve all the problems with machine learning. So it is pretty good to understand what is the problem you're trying to solve, and is machine learning is going to help you in solving that problem or not. Because there is no point in doing this exercise or following this process if you know like your problem cannot be solved using machine learning. So that is an important criteria before even you jump into the machine learning process. So as I said, like once you prepare the data, which is understanding like the columns that you are interested in has got the right data, or how are you handling like empty values in those data sets and so on. So this is called pre-processing of your data. Once you have done the data preparation, then the next thing you will be looking at is like the type of algorithms that you want to apply on the data in order to create or generate a best model that can provide you the results that you are looking for to solve your problem. So again, depending on the type of the question or the problem that you are trying to solve, the algorithms type of algorithms you will be choosing will vary, and which we will be looking at in our subsequent slides. But just understand like choosing the right algorithm is one of the key step in your machine learning process. And then once you have chosen the right candidate model or generated model that is giving you the results that you're looking for, then probably you are going to deploy the model, and then the model can be consumed by any downstream applications that really need to utilize it. So this is a typical machine learning process. How does it look like? So key processes you need to think about is like data cleansing, and that takes a key thing around like how do I make sure like the data is right in there, and if there are empty values in there, how am I going to go and fix them, and what is the right value to replace it for those empty things. So this is where you can have the conversations with domain experts to understand like okay, what is the right values to populate for those empty values before you jump onto the algorithm step. And then the next thing is around finding the right algorithm. And finally, this is not this is going to be iterative process, as you can see in the diagram. So this is not like okay, figured out finished the cleansing process. Now I'm choosing my algorithm. I have deployed it. The job done. So it's not the case. So it is going to be an iterative process. New data will be coming through. New challenges will be coming through in terms of data cleansing. And of course, the model that worked to find with the data set that you had before may not be yielding good results in subsequent months. And again, you may need to tweak the model in order to meet your needs. And this is where the iterative process of machine learning comes into play. And that is something to keep in mind. So this is not just the job done once and never looked upon at all. So let us get into the core of today's session, which is around machine learning algorithms. So before we get into machine learning algorithms, let us understand what do we mean by an algorithm. So this is what do you say, like proper definition for what an algorithm is. It's a finite set of unambiguous instructions for a given set of initial conditions, and it can be performed in a prescribed sequence to achieve a particular goal with a recognizable set of end conditions. In a nutshell, if I want to simplify this definition, I would say like it is a set of rules that you want to use to carry out some calculations in order to solve a problem. So that's what an algorithm is. Set of rules that you have to carry out in order to come some calculations in order to find a solution for a problem. So what you can think about algorithms being, it's a mathematical way of effectively finding a solution for a problem statement, which it is not going to be just a textbook problem. It's going to be a real world problem here. So what are the things that the algorithms allows you to do is like you can identify patterns and rules using algorithms. You can identify any commonalities that you can see in the data sets, and you can come up with the predictions. And of course, it allows you to classify data. So these are some of the common patterns that you can actually derive using algorithms. So that leads us to we understood what algorithm mean, what are the type of machine learning algorithms that we have got in the machine learning world. So we have got supervised machine learning, unsupervised machine learning, reinforcement learning, and of course there is a lot of organizations now doing natural language processing related things, and there are algorithms associated with those things also. I haven't touched much upon deep learning here, but again, deep learning algorithms are also available. I have kept this session to a minimum in terms of because I don't want to confuse you too much. So let us start with some basic algorithms and learn about them before we delve into deep dive into the complex ones. So supervised machine learning. So this is one of the widely used machine learning approaches. So mainly you can use that for predicting your financial results or detecting fraud or recognizing any objects in images or even assessing some of the results that you want to do. So with the supervised machine learning, your input data and output data, you know them in advance. And also these data sets or will have some well-defined labels associated with them. So that's what makes supervised machine learning is much easier, because the machine can easily train because it has got valid metadata or the labels associated with the data sets, which will help it to define the model quite easily. The next part is your unsupervised machine learning. So unsupervised machine learning is where your data set is going to be like an unknown data set where you don't have any categories or labels associated with your data set in this scenario, which means the machine learning need to classify the data based on some patterns it is identifying by itself. So there won't be any guidance given to the machine learning algorithm here. So it has to find its pattern and it has to start classifying it based on the patterns. And some of the examples you can think about for the unsupervised learning is suppose if you want to classify your customers like an high risk customers, how do you go about finding them? So this is a example like where you have to look at different patterns to define whether a customer is a high risk customer or a medium risk or a low risk customer. Then the next part is your reinforcement learning. So reinforcement learning is nothing but using a trial and error model in order to teach your mission, so that it can learn from the different behaviors, and also from providing some sort of reward mechanism. So for instance, like you can tell like if the mission is predicting things correctly, then you can just reward it with something saying like, yeah, this is good, and or you can reward it saying, no, this is faulty. So which means it can keep learning, saying with the patterns that the reward mechanism that you are giving, it will automatically learn using that. And the last part is the natural language processing. As I said, this is going to be more and more with sentiment analysis, and with a lot of social media channels and things, people gather a lot of information in terms of text, and a lot of text analysis is required these days. And that's where natural language processing algorithms will be really handy in order to find the sentiments out of some of the comments that your customers are putting on your websites, or any other like a feedback mechanism. And again, pass submit evaluations is a classic example where you can apply the machine learning algorithms in order to get your attendees feedback around what they think about the event as an overall event. So let us quickly jump on to look at some of the different types of algorithms associated with the things that we discussed, like supervised, unsupervised, and reinforcement learning, and of course the natural language processing. So within supervised machine learning, you have got three classification, like three types, which is one is a classification type of algorithms, and then you have decision trees and regression type algorithms. So within what does classification mean? So if you want to just ask a question saying like, okay, like an yes or no question. So I want to know like whether this person is going to get mortgage out of the bank, or if this person is going to sign up for insurance, yes or no. So this is like a two classification algorithm, so where the answer is going to be yes or a no. So that type of things that you can easily predict using the classification algorithms. And this is where I was mentioning like what is the type of question that you are trying to get an answer for is really important in order to choose the type of algorithm. And then you have the decision tree. So the decision tree type of algorithms is more or less like a recursive type of approach, which has got a set of rules saying like, okay, you can start with a root node, and then it automatically divides into multiple branches, and you can keep asking the questions, and based on yes or no, it navigates through a path. And the process will stop only when there is no longer there are ways to improve the response or the outcome, and that's where it stops and says like, okay, this is the outcome that you are looking for. And some of the examples that you can think about for the classification type of machine learnings is around mortgage applications, whether this particular person is going to apply for a mortgage or not, and then you can target those type of customers accordingly. And also customer segmentations, whether you classify the customers as a high, medium, or low customer, so that your marketing department can reach out to them and approach to them. And of course, the treatment effective analysis. So you can flag patients like, okay, whether they have reacted positive or negative to a particular treatment. And that is also really valuable, and you can use the classification algorithms for that. So if I look at the classification algorithm, as I mentioned, you have a two class algorithm, which is saying like a problem will be said as yes or no. So it won't be doing anything beyond that. So if your answer is like, okay, is this person going to apply for a mortgage? Yes or no. That's what you're looking at in a two class classification. It can be a yes or no, or a true or false, or a or B, and that's what it means. But when it comes to multi-class classifications, sometimes like you may have answers with common questions. It's not going to be just a or B. It can be A or B or C or D. So those type of things, that's where you go for or a multi-class classification. But one thing to keep in mind is in a classification model, you can't just go and say like, oh, okay, so is it going to rain on 2nd of December? So that's a question that you are asking. And what is the chance of the rain going to happen? And that is you can say like, yes, it will rain, or no rain, but it won't say like, oh, there is 90% chance of rain can happen. That is not your classification. Either it can say like, it will rain on 2nd of December, or it is not going to rain on 2nd of December. So that's a good example, how you can understand what a classification algorithm mean. And then the other example I can give you is more around like a lot of ISPs having these are internet service providers. They have they used to receive emails. One of the things they have to identify is whether a particular email is going to be a spam or not, and that's where classification model is really algorithm will be really handy, where it will allow you to figure out based on certain attributes you can easily classify whether an email is a spam or not, and accordingly you can address depending on whether it has been classified as spam. So this gives you a good idea around how does the classification model algorithms work, and what are the types inside that, two class versus multi-class versus image. The image is another classification type. So here predominantly what you are going to look for is what does this image really represent? Is there a person available in this, or what is actually on that image? And that's what the type of classification, like is this a image about a dog, or is it an image about a cat? So these type of things, or is there to be more specific, from a real world scenario, so is there electric meter associated in this image? So one of the use case I have got with clients is around getting their meter reading, and they can take a screenshot of their meter reading, and then you can just detect it, what is the reading from that. But for that you need to understand, okay, so what is it a meter available in this particular image or not? So you can quickly classify things like, okay, which particular image has got a meter associated with it and which ones doesn't have a meter associated with it, because that is going to make life easy for whoever is going to consume that reading information. We looked at classification, part of the supervised machine learning, and the other one is your regression. So the regression type of algorithms, this is where it is really handy, where you can do a lot of things like sales forecasting, what is the optimum price predictions that you can do for different things, and also like what is the possibility of a person going to get insurance claims based on their criteria, or is there going to be any natural disaster that is going to happen or not? These type of predictions can be done using the regression algorithms. So the key thing is around forecasting. So this can be like either sales forecasting, or energy demand forecasting and stuff, or even price predictions. Like this can be like common things like whether you are purchasing a car, or whether you are planning to purchase like power in utilities industry. That is something that they have to purchase, and it is all about forecasting the prices for those things, and how this is going to look like in the next 7 to 8 days for the different patterns that we have got. And that is where the regression algorithms will be really handy. So in a nutshell, if you look at from a supervised machine learning perspective, you either go down the path of like using classification algorithms, or you go down the path of using the regression type algorithms. And this is what the common pattern or the type of algorithms you will be using. And the reason I'm highlighting these algorithms is because if we think about using modern tools on Azure, like your ML Designer or automated machine learning, which I will touch upon in my last slide briefly, is like these algorithms are already available and you need to just choose and drag and drop. So having a bit of knowledge about these algorithms so that you know like which algorithm you can use for the problem you're trying to solve is going to make your life much more easier when you're using tools like machine learning designer or the automated machine learning. So we touched upon a few things around the supervised machine learning and the algorithms associated with that. Then you have got your unsupervised machine learning. So when I mentioned unsupervised machine learning, the machine doesn't have any guidance or labels or metadata that you provide. So it has to learn information all by itself. So this is where the challenging comes into, because what it has to do is it has to group items based on similar patterns, and that's what you call it as a clustering algorithm. So what it will do is it will find patterns within the data, and it will start creating clusters of those patterns. A simple example is marketing segmentation. So that is one of the classification, like a type you can use when it comes to unsupervised machine learning. So you can just like do basket analysis in terms of like how can you put people under different buckets, and you can just address how you want to treat them based on their behavior patterns or the usage patterns. And also like some other examples that you can think about is like the tweets. So in Twitter you can see a lot of tweets that are happening, but a lot of these tweets can be linked with a topic. A classic example is a lot of people are currently tweeting about past summit, and the topic here, it can be like past summit as the conference as a whole, or it can be the individual sessions, like whether they are attending a DBA session or a machine learning session, so they will be tweeting around those topics. So you can create a topic modeling, and also like you can start associating those tweets around those topic modeling and then finding patterns around that. So in a nutshell, like your unsupervised machine learning algorithms will allow you to identify patterns, and then it can group things based on those patterns. A classic one is the anomaly detection. So anomaly detection is a pattern or the algorithm that you can use for a pretty lot of use cases in real world scenarios, like the fraud, credit card fraud transactions that we talked about. And also like anomaly detection is also applicable in other scenarios, like where the utilities industry, which I was mentioning about, where they have to find out like, okay, so traditionally they know like the price fluctuations will be around a particular range during the day, but sometimes they may start noticing like oh, okay, the fluctuations is looking bit odd out of the regular pattern, and these type of anomalies can be easily detected using the unsupervised machine learning algorithms. And like any thing, another scenario where, or real world scenario where you can use unsupervised machine learning algorithms is like the accidents that happens on highways. So these are some examples like where you can see like there should be some sort of grouping available. When some certain combinations happen, then probably there is a possibility for an accident to happen. And again, these factors take into consideration, and you can define your models based on that. Again, this is all going to be, you can't have you can have certain amount of data to predict, but sometimes like you have to go down the unsupervised machine learning path for this use case, because you don't know what other factors that was contributing for the accidents that are happening. So the machine will automatically start grouping some of these data sets, analyzing these data sets and grouping the patterns together in order to provide you an outcome. So we looked at supervised machine learning algorithms, unsupervised machine learning algorithms, which is your k-means algorithm, the market basket analysis, or the anomaly detection algorithms. The next part is around reinforcement learning. So there are two key algorithms that are associated with reinforcement learning. As I said, reinforcement learning is about like you are giving credits so that you know like whether the mission can detect saying like, oh, okay, is it going and predicting it on the right track or not, and it can fine tune its predictions based on like the rewards that you're providing to it. So if you give a reward, it knows like it is going in the right direction, but if you give a penalty, then probably it knows like, okay, it has to tweak back and come back to you with a better response. So where reinforcement learning is really handy in real world scenarios is like for business strategy planning, robotics. If you think about a lot of industrial automation, that's mainly used through reinforcement learning algorithms. And of course the aircraft control. So if you want to control those type of things, again, that comes along around the usage of reinforcement learning algorithms. So we have got two algorithms in here. One is the Markov decision process. So where you will be performing a set of actions and there will be a set of states associated with those actions. And then you have a reward mechanism based on a policy. And then the reward mechanism will decide based whether you are yielding the right result or not. And that's pretty much the Markov decision processes. But then the second algorithm you have got is the Q learning. And Q learning is basically like you need to understand. A simple example to give you is like if you have a house and if you have a lot of rooms connected by the doors, and if you want to reach to the target door or something, then probably like each door will be numbered, and if you go through the door and if you reach to the target, then that will be given a brownie point or your reward. And if it is if you're going through a door but it is not reaching you to the end goal, then that is a pattern where you'll be just giving not a brownie point here in terms of like you'll be saying like, okay, you are going to not get a reward here, but instead you will be getting a penalty point. So that's what the Q learning. So this is based on the value based method of supplying information using which the action the agent needs to take. So here you are guiding through saying like, okay, this is the goal that you have to achieve. And then it will be navigating through a series of actions in order to try to achieve that goal. So these are the two different algorithms that you can get out of the reinforcement learning, which is pretty much used in a lot of real world use cases, as I mentioned. So then comes your natural language processing. So I think a lot of you have been exposed already to Q&A Maker on Azure. So you would have used a Q&A Maker in a lot of examples. Like Q&A Maker tool is mainly used because it can extract keywords out of a lot of manuals and documents, and then you can start asking questions and it can automatically provide you answers related to the questions. So mainly natural language processing algorithms deals with a lot of text-based data. And what are the things that you can do with that is like you can identify topics, as I mentioned, the Twitter example. You can do sentiment analysis of your data. This can be sentiment analysis on the tweets or even sentiment analysis on the different type of comments that you are getting from your end users about your website or your product. And then, of course, you have got text to speech translations, voice recognition type of things like, okay, you can find out some patterns around voice recognitions, and also like a fake news recognition, which is like which is really important these days, because sometimes you don't know whether what is a trusted news versus what news have been spread for the reason of spreading like a fake news. And then the any interpretations of the data. So the type of algorithms you mainly use in the natural language processing is around the feature hashing algorithm, the pre-processed text algorithm, or word to vector based algorithms. Again, you don't need to go into the complexity of getting down to understand these algorithms, which I'll talk to you about in the next slide, like how do you go about choosing the right algorithms, or if you want to get down this path of learning, what you need to really do. So just keep in mind that these are some of the algorithms that are related to natural language processing or NLP. So now we are coming to the actual question here is around, we looked at some of the types of machine learning, which is supervised, unsupervised, reinforcement learning, natural language processing. We also saw some algorithms associated with each type of the machine learning types. And what we have to now choose is, how do I choose the right algorithm? And what do I want to do with my data? So Microsoft have provided you an algorithm cheat sheet, which I have linked in the reference. Let me quickly drag that particular cheat sheet here to give you an idea. 1 second. Okay, so this is the cheat sheet I was talking about. So here, if you look at it here, so what you want to do. So this is the problem statement that you are trying to solve. And it gives you a clear guidance of what is the type of path you need to take and what is the type of algorithm that is going to help you in order to solve your problem. So for instance, like if I want to generate recommendations. So this is the example I was talking about around books I'm searching for, or the things I search on an e-commerce website, or even things related to like, okay, I'm looking at movie reviews. So okay, what is the type of movies that you will be recommending based on the my interests? So these type of if you want to generate recommendations, then this is the type of algorithm SVD recommender you will be using. And if you are looking at to discover the structure, so which means like you want to do grouping or clustering of your data, then you will be using k-means algorithm, which is part of your unsupervised machine learning. And if you're talking about prediction between two categories, like you use a two-class classification. So, and this is what we were talking about, like a simple yes or no or a true or false type of questions that you can ask. And again, as you can see here, within this two-class classification, there are quite a few algorithms. And again, these algorithms we will be choosing based on the parameters. I'll briefly touch upon these parameters because this is really important to understand. So when I talk about parameters, so what I'm talking here about these additional requirements that is highlighted in the slide in terms of accuracy, training time, linearity, number of parameters, and number of features. So let me explain what each and every of this requirement really mean. So accuracy is like uh, always getting the accurate answer is important, but not always important, because if you can get a certain level of accuracy like 80%, 85%, then you can just like, you don't want to always wait for that 100% accuracy, because in that case you will be just trying to overfit, finding a model that is going to be overfit. Again, you will have this problem when new data comes in, like if you want to try to achieve. So always draw a margin somewhere to say like what is the level of accuracy that you are aiming for. The next attribute that you have to consider when you do machine learning models is around the training time, because sometimes you may be dealing with a whole heap of data, huge volumes of data, and also a series of algorithms that you want to try. And so what you need to make sure is if that particular training is going to take days and days for you to get an outcome, actually like you will lose certain, what do you say, like you can easily lose the time. And so for instance, like when I say the electricity market predictions, like they want to make decisions in half an hour, right? So they can't sit there, and if your model is taking like even 2 hours or 3 hours, then actually they lost the time. So they can't use that prediction for a time that is already gone past. So sometimes for your use cases, the training time is limited. And when the training time is limited, then it can drive the choice of algorithm that you're choosing. So I will correlate this with the other PDF which I showed you, but keep a note in mind, like a training time is an important attribute also to consider. Then the next thing is around linearity. So if you think about a lot of classification models, the linearity that is important, because the data will automatically assume there is a trend here, which is a straight line. And these are not, like linearity is important. And again, having a bit of accuracy around that is also, like a range of accuracy around that also is important to consider. And the number of parameters that you choose. So the training time and accuracy, as I said, it can be more sensitive, but also like you need to figure out what is the type of parameters I'm going to use. The more number of parameters that you're going to use to influence your model, then probably that is going to like give you a lot of variations that you need to look into. So always sit down with your domain experts and find out what parameters that you can pick and choose, and keep it really minimal. And that will help you to reduce the number of iterations that you need to go through to find your optimized model. And last but not the least is the number of features. So if you are looking at comparison with a lot of data points, then make sure like you have got a limited number of features again. So the large number of features you can have, that can easily bring down your to like finding the right algorithm for your problem, as well as like making the training time really long. So keep that in mind, because these are some of the additional attributes that will guide you for your problem to choose the right algorithm. So let me get back to that PDF. So here, now I have taken you through the different attributes that we were talking here. So here, when you talk about like, okay, if you are looking for a two-class classification, a yes or no, but you want to have a faster training with a linear model, then you can go for a two-class averaged perceptron algorithm. So similarly, like you can see here, now you can fine tune your algorithm choice based on the different attributes that we have been discussing. So that's two-class classification. And then you have a multi-class classification here. So this is mainly to answer complex questions I talk about, because not always your questions will have A or B or a yes or no. Sometimes you may have a list of options and you need to choose one from that list. And that's where the multi-class classification and the algorithms associated will be handy. Then you have your text analytics, which we talked about, which is around extracting information out of your text-based data, and the algorithms that are available listed in here in this cheat sheet. And this cheat sheet link is also linked in the PowerPoint references section. So a few other things is around finding unusual occurrences. You can use the anomaly detection and classifying images. Then you can use the DenseNet algorithm. So some of these things are already folded inside the cognitive services and the automated machine learning type of tools already. So you don't need to really need to know the internals of these algorithms, as long as you know like, okay, this is the algorithms that are being used, why they have been used in those models. The last thing before I move on from this particular PDF to highlight is the regression ones. So the regression ones is the one that mainly used for your forecasting things. So the reason I'm highlighting these type of algorithms is most of the business scenarios can be solved with these type of algorithms itself. Like I'm talking about general use cases which typical organizations have around forecasting, price predictions, recommendations that needs to be provided, image classifications, and anomaly detections on different use cases, as well as like where you have to go out of the box from here is if your data set is particularly unique, and if your data scientist is not happy with the outcomes that are produced from these models, and then that's when you need to go and work on your custom modeling based on the attributes and the data sets that you are looking for. Otherwise, like majority, I would say majority of the real world use cases can fit into any of these algorithms quite easily. Let me get back to my slides here. Cool. So how do you go about selecting the machine learning algorithms? Use that cheat sheet, and that will help you to guide. And of course, like as I said, the key thing to understand is what is the question that you are trying to answer using machine learning. That is a key attribute. And of course, some of the challenges which I mentioned around having the right amount of data. So you can't go for a supervised machine learning if you don't have the right like labeled data or things available. So these things, that is something to keep in mind. And also not all the problems can be solved with machine learning. So you need to figure out like, okay, is this the problem I'm going to solve, is can I use any of these algorithms, or have I got the right data even to use any of these algorithms? That is an important aspect to consider. One typical question which normally I used to get when it comes to machine learning is like, okay, our organization doesn't have a lot of data. We are new and we are setting up our enterprise data warehouse. Like, are we good to do machine learning? And I would say yes. Like you don't need to wait for saying like, okay, I have to wait for next 5 years to collect the data, then only I can start doing machine learning. So initially, like sometimes doing supervised machine learning because you don't have labeled data or things that is readily available, that can be challenging. But unsupervised machine learning, where the machine learns based on the patterns that are seeing in the data as and when it gets accumulated, that is a good way to even start with and start finding the predictions in there. And as I mentioned around the data sets, so machine learning process is an iterative process. So your data, even on a daily loads, if it is coming, and it is periodically, you need to check the accuracy of your models, like how the models still, whether they stay intact with the new set of data that you are receiving in your organizations. So long story short, like if you have a question in your mind around saying like, okay, I don't have enough data sets, can I still do machine learning in my organization? The key thing is it's not about just the data, it's all about like what is the problem you're trying to solve. That is also important thing to consider. So just a quick thing around the machine learning tools. So I'm not going to deep dive into any of these tools or show demos around these tools, but I want to just to give you a glimpse of what tools are available on Azure. And I think in Leela's presentation, she will be covering around how do you go about solving a problem using automated machine learning, and how does it automatically pick the different type of algorithms based on the data that you are going to feed, and it is going to give you the outcome. So you will see that in her session. So what you will be looking here is around the different tools that are available. So the ML Designer is a graphical user interface tool. So you can drag and drop the different things in terms of the machine learning process that we discussed, which is around preparation of your data, cleansing your data, and splitting the data in such a way like certain amount of data or percentage of data goes for training versus the remaining percentage of data will be used for testing once the model is generated. So all these activities can be easily used. You can create the whole process using a drag and drop mechanism using ML Designer. ML Designer also supports out of the box algorithms available that you can drag and drop and use with your data. And there is a lot of use cases that are already available in terms of the forecast modeling, price predictions. So if you go and look at the Azure Machine Learning ML Designer, that you have a lot of sample data that will allow you to get started and use these particular algorithms out of the box. I think there are around 25 plus algorithms available on ML Designer that you can go and use it. And of course, use the cheat sheet, which I was highlighting and mentioning it to you. The next tool you have got is automated machine learning. So one more question that comes mostly when it comes to machine learning is, what is the level of expertise? Do I need to have data scientists in my organization in order to do machine learning? And if that is the case, how many data scientists I need to employ in the organization? And this data science is not an easy topic, where you can just go and train them and immediately they become experts. So this is a process that you have to go through. But where automated machine learning can be handy is there is a, as I said, there is a lot of common problems across industries. Like for instance, the price prediction. So the price prediction is a common thing across different industries. So where you can use predefined or known algorithms in order for price deductions, and then you can start using automated machine learning, which will use these algorithms on your data, and it will automatically rank you and tell you okay, this is the right algorithm for your right problem. And that's where automated ML tool will be really handy. The notebooks, so this is for hardcore data scientists, who doesn't like to use these graphical user interfaces or the automated machine learning for some complex use cases that they have got. They have to create or they want to create their own models. So you can think about these things around system administrators or DBAs. If you go and give to DBAs, okay, here is a graphical user interface, you can find out what queries are running slowly and things. Even if you give that, they would prefer using the DMVs, because from their perspective, DMVs are really cool to use. Same thing with the data scientist role also. They would prefer to use notebooks in order to generate their models rather than creating using the graphical user interfaces or the automated machine learning. So for your data scientist to hand code these models using their preferred language like Python or R, they can go down the path of using the notebooks. So that's pretty much what I really wanted to cover in this session. So this is more around understanding what machine learning is, what are the different challenges organizations have with the machine learning, and how do you go about understanding the machine learning process. Where does the data cleansing fits in versus where does the choosing the right algorithm fits in, and what are the different type of machine learning types you have got, and how do you pick and choose the right algorithm in order to solve the problem. So some of the references which I have been quoting in my session today, I have just linked them here. So you have got the ML cheat sheet as well as the list of algorithm. So I'll just share one more link here, which is again available in here. So this is one of the thing I was talking about. So some of the attributes I was mentioning in the session around the algorithm and what is the accuracy, what is the training time, what is the linearity, what the amount of parameters that you can use. So for each and every algorithm that you saw on that particular cheat sheet, here you have got you can pick and choose okay, what is the right one based on the different attributes I have got. So I want to have a faster training time, then I can go and pick and choose the right one that is going to help me in to find the solution for my problem. So let me get back to my slides here. So that link is also available for you to have a look in here. And there is this link which is providing you the algorithm module reference. So let me quickly check this one. So what this gives you is the different type of algorithms and then you can drill down to each and every algorithm, and you can get a better view of these things. So this is going to be really handy. As I said, with Azure Machine Learning, a lot of these things are predefined. You need to just to pick and choose. But if you want to get a bit more background information, understanding about these algorithms, feel free to navigate to these references to get a better background information. So with that note, I will just wrap up the session. So hope you will had a better understanding about how do you pick and choose the right algorithm for your machine learning problems. And if you have any questions, like put that on the, like I'll be taking up the questions shortly. And also like if you have any questions post this session at a later point, feel free to reach out to me. I have got my Twitter handle as well as my email address here. And with that note, like thanks for attending my session, and hope you are having a good time at PASS Summit. I think thanks to PASS for putting through, and all the sponsors and volunteers for putting through this event even during this pandemic time, and the virtual event is really cool.
And if anybody has any questions right now, we're taking questions for a few minutes more. Feel free to put them in the question board. We do seem to maybe have one here. Oh, thank you for the session. You're welcome.
Yeah, so like while the questions are coming, I can just talk about the algorithms a bit more, like machine learning algorithms, because I think the challenge is always with organizations like picking and choosing the right algorithm. And the question is around like, do we need to have domain experts, and how many domain experts we need to have in the organization? And also like whether developers can do machine learning, create machine learning models. And of course, like with the tools like Azure that is currently providing a bit of background around these models, which I gave you a glimpse today and an introduction about that. And if you delve down in using it in your real world scenarios, even developers can just go ahead and use these tools to create models for some of the common use cases that are already a lot in the market currently.
Okay, we'll just hold on for another minute or two just in case there's any other questions.
Sure.
Okay, if there's no more questions from the audience, on behalf of PASS, we'd like to thank you for attending this session.
Great, and thanks everyone for attending the session, and thanks for the moderators.
Fantastic. I hope everybody enjoys their day.
Thank you.